Okay, can you see my screen now?
Can okay.
Okay, good. Then- okay. So basically, what we did today during our uh, 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 today class earlier, so we have been showing you the introduction, a brief introduction on the what advanced suspension system. Okay, on the advanced suspension system, the one that we learned on the derivation is actually the derivation of right comfort model, only involving a passive suspension system. So when I say about passive suspension system, it only consists of a normal spring and a normal damper. So we already modeled the what right comfort using the quarter car model, half car model, and full car modeling approaches. Okay, with the degree of freedom for this model different. With the quarter car model, we have 2 degree of freedom. Half car model, we have 4 degree of freedom, and full car model, we have 7 degree of freedom. So the higher the degree of freedom is actually better for us to evaluate the right comfort performance. Okay, now today you will be introduced on the advanced suspension system. It's just a brief introduction because if I'm going to introduce this topic and then it takes a longer time. So basically, I'm covering this advanced suspension system for at the master level. Okay, it just this one just going to be introduction for you guys. Okay, and then for the advanced suspension system, it can be further being divided into two types of suspension system. Which the first one is we call it as a semi-active, and the next one we call as an active suspension system. So the main differences between the advanced suspension and the conventional suspension is actually the type of actuator or shock absorber or damper used in the suspension. Okay, now for the semi-active suspension, we have the damping element, whereby it usually being drawn in a way like a small arrow crossing the damping element, showing that this shock absorber or damper has a variable damping coefficient, where the damping coefficient can be changed depending on the road profile, and of course this one is going to be controlled by control system, which I show you using the TID control structure. Okay, um, and then this damper, furthermore, we can typically we have two type of variable damping shock absorber or damper. The first one we call as magnetohydrological damper or MR damper, and then the next one is called variable orifice. So magnetohydrological damper is actually the latest variable damping damper introduced into the market compared to variable orifice. And I think the variable orifice already come out in the 80s, if I'm not mistaken. But for the MR damper, it comes out in 2000, firstly being introduced in 2000. It did not become a trend until 2010, until now. Now, most of the mid-price cars like Camry, and then most of Continental car in US, they start using the MR damper as the damping or shock absorber element in their cars model suspension system. Okay, now in Malaysia you can see it in Audi A4, A5 and above. Okay, and then Audi Quattro also be using the magnetohydrological damper. Okay, okay, the working principle for MR damper. I'm not going to go into details. So basically, just instead of using normal fluid or oil. So in MR damper, we have we have iron particles that being immersed in carrier fluid. Usually, can be oil, can be which is synthetic or mineral oil. Where whenever this oil, a mixture of oil and iron particles being introduced with magnetic field, they're going to harden. Again, you can see the video of MR fluid or in the MR damper in YouTube, whereby you can see that the fluid are going to come hardening. So these changes from liquid to the semi-solid, from liquid to semi-solid, and then semi-solid to liquid bag, you can see the differences when it's being introduced to magnetic field. So these are these characteristics being manipulated inside the shock absorber, whereby we're controlling or introducing what the magnetic field at the orifice or the what the opening where the fluid need to go through. Okay, so by controlling the magnetic over there, it's like whenever the MR fluid change into a semi-solid state, it's actually going to clog this orifice or the opening of the fluid flow. So when that happens, the damping coefficient is going to increase. Okay, when the magnetic field being removed, and then the flow going to go back to original flow. So by keep on switching on off, or varying the magnetic field, we can we can control the damping coefficient value for the shock absorber. So that's how the MR damper will be controlled. Okay, so further you can do your further reading on this MR damper. And then we have another type of advanced suspension system, which is for the active suspension. We have slow active and fully active, where in slow active we still have a normal damping element and normal spring element, whereby we just add actuator to the suspension system, where this actuator, the function is not to absorb the shock, but more likely to do the correction of the cast leveling. So especially when cornering, so when we do cornering, the car tends to do roll, and then the suspension going to lift up the car to do the correction on the leveling. Okay, so that's all we did on the slow active. But fully active, this is the example on what you saw earlier today, where we saw on the Bosch suspension, where you can see that if given any type of road condition, it can still maintain the chassis level. Okay, meaning that by you can see that during when the chassis keep or be maintained at the same level, there's nothing, there's no roll motion, pitch motion, or excessive vertical motion at the sprung arms. Uh, that one can only happen if the unsprung mass being allowed to move excessively. Okay, and then this not only happen at the straight driving, but straight driving low speed, but it also behaves the same thing by maintaining the chassis leveling at high speed during cornering. Okay, so that's how the fully active. So okay, now I also introduce you the actual our control system. So you learn about in your control system previously in control system. You learn more about the response of electric motor involving the PID controller. So what we learned in your control subject, we're going to it's just introduction. Now we're going to look on example for automotive application, where in automotive application or any mechatronics or mechanical electronic system, the control structure is like this. So it need in order for us to do the study, usually we're going to work on laptop or desktop, where we study via simulation, and then that simulation has the simulation model or plan, and then it needs to have the algorithm, and it needs to have the actuator. So this is typical general layout for control system that being studied or being used both in by researchers at university, as well as the when you go into the R&D department in OEM. Okay. And then this is what we call as actual system. And then okay, one more thing, you don't have to worry, because this type of work, when you go into in automotive industry, your OEM or car manufacturers don't do study about this. Most of this one being done by the vendor, especially the those who are being supplying the what ECU module to that manufacturer, car manufacturer. So such as we have Bosch, and then we have what uh, ZF, okay, those the big vendors that typically work on the chassis control technology, okay, ASC, APS. So they're going to use this same approach. And then we have another type. Okay, this one we have an actual system where we have actuator, the one that going to really implement what being calculated by the algorithm in order to what to achieve whatever target we want. So let's say that we want the car to maintain its what is leveling. So no matter how the cars or road condition is, the algorithm going to do the estimation, and then the actuator going to try to execute the algorithm calculation, and then the actuator going to apply that any kind of forces motion to the vehicle model. So from there we can see the improvement. Okay, now this is the general layout, and then the second one what we call as an idle system. So this one is without actuator, so meaning that you have the plant model, and then whatever the feedback that you want to consider for your algorithm, and then when the algorithm do the calculation, it's going to be applied directly to the vehicle model with the assumption that force or anything that being estimated by the algorithm, can be it the torque, the damping forces or forces or moment, that one will totally 100% can be created, or the actuator will totally 100% able to create it and apply it to the vehicle. Okay, this is the ideal one, and then this is what the example for the semi-active suspension system via ideal case, where we have the vertical prong mass vertical acceleration, uh, where we compare it with the reference value of vertical acceleration, whereby ideally we don't want this prong mass to move. Okay, so if it does, if it moves, so there's going to be an error. So that error is going to be used by the PID to estimate the damping force. Okay, which this damping force is the one that being applied back to the Quadcam model. So I already showed you earlier in our PID magnetic suspension system, where we have this is the actual implementation of advanced suspension system in Simulink. Okay, I'm using this one for semi-active suspension, but for slow active, sorry, for the active suspension, we're going to be do like this. It's just that we need to disable the spring. Okay, that one fully active. But for the slow active, we're going to use both KS, CS, and then for this part, for this summation, there's going to be another element or put another sign which is going to receive or accept the value from the SFD. So that is for slow active. Okay. So okay, any questions? This is what the recap of what we learned today, earlier today. So any question? Because I'm going to go with the doing the user interface for the simulation model using dashboard block. Any question?
Clear, Doctor.
Okay, clear. Okay, now we're going to go for the so for today we're going to create or learn on the how to create the graphical user interface of for our simulation model. Okay, because for research student, so later on if you are in the future, if you are thinking of continuing your study, or even when you want to work with industry, so this kind of able to do the setup, experimental setup, or to study the mechanical or mechatronics system on your own. Okay, it's actually a good advantage because first you don't have to rely on other people to do this work. Okay, but nanti whenever you go back start working with the industry, which requiring you to do the experimental setup. Usually, before you're able to do that, there's a lot of process. Okay, meaning that you need to do the proposal, wait for the proposal to be approved or rejected, and then you also need to include your team members, and you do not know either that team member is going to cooperate with you or not with your work. So to avoid this, do it on your own. Okay, and then to do it on your own, at least you know the on how to do the expensive setup, especially when involved the mechatronic or mechanical electronic system. Okay, and basically out there, there's a lot of software or hardware that you can use, and typically it's going to be very costly. Now with the IR 4.0 era, so we can reduce that cost. So we have Arduino, we have Raspberry Pi. We can actually skip using very expensive control system or hardware, especially National Instrument or DSpace. Okay, they want very costly. Because even though that is very costly, doesn't mean it's good. Because usually when it goes back to the control system, what the price or the specification that being sold to the OEMs is too high, because sometimes you just need to do a simple control system. Okay? But yelah, kalau tak ada Arduino dengan Raspberry Pi, you don't have any other option rather to buy that very expensive hardware for control system. But now we have the Arduino, we have the Raspberry Pi, you can use it. Okay, okay, now we're going to create the graphical user interface. Graphical Probably. Okay. Post mention model. For simulation model, we can also bring use this guide, the general guide for experimental setup, which is simulation model or experiment. Okay, or for if you want to acquire data, so you can use the same approach or guide. Okay. Okay, the most basic of your graphical user interface is that your GUI GUI element. Okay. You need to have input, you need to have output, you need to have nodes, okay, and then it needs to be properly arranged. Arrange. Okay. Okay, properly arranged. So when I say that the inputs, okay, let's say that we want to create a graphical user interface of a Kotka model. So I'm just going to show you. Okay, this is, let's say that this is your interface. Okay, basically this is the interface for graphical user interface. Usually we need to have, remember, you need to have the input. Okay, typically we're going to have the input over here, left side. So this is going to be your area for input. So whatever it is, so this is the input. And then for your output, so usually we're going to have graph over here. Okay, this is your graph. And then your node, usually if you are looking at the for what software or interface created with Visual Basic, everything they has nodes. Okay, so in form of tanda soal. Okay, but okay, a good example is the Simulink block itself, where when you click the block, it has the input, and then it has the node how it can be used. So the concept is the same, which is okay, for your nodes, maybe you can put can conclude it over here. Maybe you can put type notes over here. Yeah. So this is just an example of arrangement. Okay, but of course, your GUI need to have these 4 elements. Okay, output, input, output nodes, and properly arranged. This the arrangement is basically going to depending on the person creativity lah, how you want to arrange your elements in the graphical user interface. So you can put maybe nodes over here, small nodes, big nodes. nodes. Okay, then this is your output. Then this is the output. And then we can have and then the output we can have another many kind of output. Okay, output we have okay, okay. Okay, and then for output can be okay, for input can be your value constant. It can be in terms of switch. Mm, mm, okay, in terms of input, okay, your input can be in the form of a value. It can be in the form of a switch on off. Okay, and also it can be in form of toggle button. Same thing lah, same function as switch, toggle or radio button or button. Okay. And then for your output can be in the form of it can be in the form of this one graph, uh, status indicator or LED. Either you're going to switch on red or green color showing the status indicator, or it can also comes with a value or display. Okay, and then for nodes it's just nodes, and then for properly arranged, so this one depending on you see the what we call what user experience. So this one there is no a proper way in doing that. It's more like experience, and you can also refer to other typical graphical user interface for experimental or for experiment lah, using for apa using LabVIEW control lah. Okay, and then input. Okay, the node here can be in the form of the output can be in the form of value, and then also in the form of graphics. So meaning that whenever the output is given, you can see that, let's say that quarter car is moving, or there's some the quarter car keep on showing you compress and extend, compress and extend, showing that it's working, your simulation is working based on the value. So any question about this element? So this is the summary of the most basic element that you need to have when you're creating graphical user interface, and we're going to implement it in creating user interface for the MATLAB simulation. Okay? If you know how to code in Python, how C++, so that one is your advantage lah. Okay, but okay, but for now, for this class, we're going to implement this graphical user interface using MATLAB simulation. So any questions? We're going to do the hands-on on the using the vertical model that we have. Okay, ada soalan?
Doktor.
Yep.
GUI untuk doktor buat ni kat dalam Simulink kan, boleh extract ke mana-mana software lain?
Boleh.
Masuk ke Rhino ke?
Okay, dia macam ni. Okay, itu yang saya nak, ini yang saya nak beritahu ni. Dia sebenarnya bila kita yang Arduino tu kita boleh buat, maksudnya you create your Simulink, the interface in using Simulink, and then decode everything here you see along with the dashboard block. You can burn it into the Arduino. Okay, it's just that. Okay, it's just that it's going to be very slow lah. Okay, sebab Arduino tu dia depends on Arduino. If Dual, it's still going to work, but if you're using a small sampling time, they're going to be going to stuck lah. Sebab being put a heavy burden. Usually, my suggestion is that usually when my experience that I'm going to burn everything in Raspberry Pi, because Raspberry Pi has the high the punya RAM tinggi, the highest one is 8 gig, and then all the data acquisition being acquired by the Arduino, and then Arduino will pass the data to the Raspberry Pi for the processing. Okay, sebab Raspberry Pi we have the input channel is just digital. Okay, most of the sensors that we have for our easiness, usually we prefer analog or anything that has support log inside the inside Simulink lah for Arduino. So we use that log for Arduino. So the Arduino being integrated or assembled with the sensors just to do the data collection. That data then later on will be passed to the Raspberry Pi through the serial connection. Itu advanced sikit lah. Okay, saya boleh tunjuk tapi tak ada masalah. So kita buat fokus yang step by step. So we're going to focus on graphical user interface for simulation dulu. Okay. Yang for Arduino tu saya tak suka kot. Mungkin later on saya tahu mungkin tanya untuk subjek apa auto design kan. Itu saya akan cover kemudian lah. So okay. Okay, faham eh?
Okay, Doctor. Thank you.
Okay, good. Any other question? Yeah, tak ada. Okay, so kita start lah. So basically, when you want to start the graphical user interface, basically we're going to keep our Simulink model aside. So basically, the first thing that you need to have is your background. So let's say that based on this simple notes, this is your graphical interface, meaning that this is your window. Okay, for the first window is we need to have this one, the working area for your graphical user interface. Okay, like this one. If you want to change the color, usually we're going to use this color. Okay, and then based on this one I'm just going to show you just straight to the point of graphical user interface. Just to you the blocks and what you can do with Simulink in terms of creating your own graphical user interface. So this is the working area window. So take it from here, from area, and then we want to create a category for our input. Same thing, we put the area here. Okay, I put it here. Then we type it as input. So for input, we have now we want to type the name of it. It say nest tadi punya. The arrangement for the unsprung mesh. You and just the for Yes. Yeah, damping business. Yes. Then we have tires business. Now, we need to create the new one. This is just a layout. Later on, you can do the resizing later on. But first, put the information, all the information needed for your graphical user interface. Okay, go to library, go to the dashboard. So we're just going to select the, okay, this is the value or edit block. So maybe you can do some resizing. Now and done. So this is it for your input. So when you want to move everything, so you just move the what we call this one as palette. So you're going to move in form of category lah. Okay. Now we want to put the graph. So let's say that you want to observe the graph and we just want to take a look at the graph for the ZS double dot and uh, ZS with ZR. Okay, so we're going to put two scope or two graph. So we have the same under the dashboard. So go to the dashboard scope. So for this one, for dashboard scope, usually it going to when we click run, the scope will the result will be displayed directly in here. We don't have to double click the scope block, or we if the result won't appear in what black background of a normal scope graph. Okay, the result going to come out directly here. So we put it here. In form of plane because it's going to easier to move later on. Okay. Then change the color. So the same one, this one is gray. Okay. Now we have the input and then we have the output. So this is the most basic. Okay, I'm just going to show this one, and later on I'm going to show some advanced or tips and tricks on what you can do with this graphical user interface. And of course over here you can put your notes or you can put the picture of Kotlin model. So for example, I'm going to take the Kotlin model from the internet. It's, uh, Okay. So I'm going to insert the picture over here as a note. Okay, like I told you, notes can be in form of graphics and also it can be in form of text. Okay, so we can put it here or put it here. Never mind. Okay, this is your image, so you need just to resize it. Okay. So this is your cortical lah. So definition of this brown mass, brown mass, spring thickness, damping coefficient. Yes. Then of course over here you put some text lah. Note and this is the example lah in the input value. Okay, two, five, one, okay. Okay. Ni yang basic lah. Saya buat ni untuk apa? Okay, itu je. Okay, now okay, this is actually the um, okay, now we already right now you're seeing on your left side is the graphical user interface for the Qualcomm model, and this is our model. Later on we're going to hide this one, but for now we need this model because we need to assign the block of input value to this input block display from the dashboard. Okay. Okay, now we going to assign the ataupun what you can do is that instead of clicking the value inside here for MS, MU, so what you can do is that just assign the constant block. Put it here, okay? MS, MU, AS, yes. Now, because okay, now we supposedly we are supposed to click or link this field into the block inside the block inside our model lah. But to make things easier, we can also put this constant or parameters name outside of this subsystem folder and then assign it to the parameters name. It's still the same thing. Okay, we're just going to make our work doing the assigning the parameters name with the block much more easier. So when you have this constant, we cannot leave this one like that. We need to put the ground. Okay, ground mean you can go to sync, or we're going go to terminator. Okay, or maybe you can put anything like just to close the loop. Maybe you can put this one. Just, this one is just going to act as a dummy. Make sure that there is no error. Just, now we need to assign this block to this block. Okay? Now just double click. You need to remember, just click it. The edit block parameter is going to come out, and then select. Just click the connect area, and then just select the block. Then update. We need to put it the parameter name first inside the mallet main interface. Okay. And put it. Okay. MS equal to 250, MU equal to 50, S equal to 100. Okay, now it's already been signed, so we just can click it. Okay. Okay, just select your M. Okay. Then select your MU. Just select this one. Apply. Okay. Then select your spring stiffness. UKS. Just select UKS. Okay. Then select your CS. Okay. So any value that we already key in the workspace, it will be updated here. And also when we change the value over here, the value inside the workspace of MATLAB also going to change. Okay, so that is okay. Now I can see that font size, so we just reduce the size because we have a small block. Okay, there you go. Okay, got it? So now talk what we are going to do this with this one. Okay. So this is, you can hide it. Okay. The way that we hide it is that this pixel system over here. This form will be blocked. Or maybe we can do is try run. Is there any error? Okay, we haven't signed the what the dot to the scope. Okay, there's no error. Never mind. So for this one, uh, okay, maybe we can delete this one. Then put the this. can just hide it. It's on. Or maybe letak terminator. So you can use port or you can use terminator. If you use port block, then you can see there is opening or what at your subsystem. If you use terminator, then there is no the constant block won't be channel out. Just check this out. Whether it's going to terminate or not. Okay, now this is your model. You can put it over here. You just hide it, make it. Just hide it because only you know that what does it mean block. There you go. And this is your your interface. So now we need to click this response. So we click it. Now we select with the JS. That one. So just select this one. We need to select the signal line. So let's say I'm selecting the JS double dot. Okay. Select line. Go out. So this one I'm selecting the ZR. Okay. So just sorry, I'm selecting ZU. ZS, sorry. Okay, ZS. Right. Let's check. Can it be run? Can we run it? Yes, there's the result. Okay. And then so this is the graphical user interface, the straightforward graphical user interface for you to know lah if you want to use MATLAB Simulink. And also the same guide can be used if you want to create data acquisition system using Arduino or using Raspberry Pi. Okay, or communicating between Raspberry Pi and Arduino. Everything can be done using MATLAB Simulink. Okay. Okay. So any question about this example before I'm going to go for the tips and tricks? Any question? Any question?
No, doctor. Everything clear.
And then, okay, let's say that we want to add, okay, you need to remember that for each scope, we can also do the import. So you just need to select the same graph and then go back to the system model. Then select your ZR. Okay, so we can select both. So meaning that you're imposing the result at the same time. Right? Run again. So you can see that there's a two result over here. And then, okay, so this is based on this one. Okay, now let's say that okay, usually if you take a look at other normal software, basically to see the result, you're going to have option. There's going to be option. Either you want to see the result or not. Okay, if you want to see the result, you're going to click the radio button to opt for the result to be displayed, and then you click it, untick it again. The result will be unticked. So the same thing can be done using the dashboard block. Whereas you can see under the dashboard, there is function for the button, radio button, or knob. Okay. Push button, radio button. For example, I'm using the radio button. I'm going to select run. Okay. I'm using the register button. So let's say that I want to select no. Never mind. It's not too many things to do. Okay, so basically, if you can, let's say that you want to use the switch, let's say you want to use toggle button. We want to toggle between, we want to enable the result to be displayed or not. So we just use a toggle switch. So do you have many types of switch? You can have toggle switch or slider switch. And we have a rocker switch. Okay, and because this toggle switch is just going to give you a value of 0 and 1. So if you toggle it into on position, it's going to provide you with the one value, and then that one value you're going to use as a what constant to multiply with the result. So you can so something multiply with one, you're going to get something back. But if the value is 0, then you multiply with that data or that what you want, so that nothing will be displayed. So that's the concept. Okay, so I'm going to show this one. So you can play around later on. So let's say that okay, this one using the S double dot. Sorry, okay. Let's say that put it with the GR. Okay, I'm putting with the gate. Hmm, no, no. Let me see. So double dot. Okay, okay. So meaning that when I toggle the toggle button to one, so meaning that the S double dot, alamak nanti dia akan bagi error. Okay, never mind. So this is not a good example. Because when you change to 0, so this value will be used to the next phase. But since that the value is 0, so everything going to create a hair wire. Okay, never mind, this simple one. So you just link this button with on off of your LED. Okay. Yeah. So you can later on you can start exploring how to manipulate this one. Okay, so I'm going to use okay uh, on one off is 0. So I'm going to click this one too. Okay, you need to select the signal in simulating data. Now you still need to use a constant. So never mind, you put the constant. This terminator. Then select this block. This one. Okay. So when you change, you toggle, you click this toggle switch. You're going to change the value in here, and then the value in here will be used by this one. Okay. By to light up your LED. So meaning 0 is the red. Add another one. 1 is going to be green. Okay. Oops. That is one. Okay. Okay. So if you toggle off, so you see the value is 0, but this one is not showing you any color because we're not running this simulation yet. Okay. So let's say that I'm running the simulation for infinity. Okay, so change it. Oops, cannot do this one. Um, what? Okay, there you go. They can see that there is a color. If change to one, the value to going to change. So this is the basic one. So later on you can start manipulating this buttons and LED. Sometimes you can relate it with our processing, so meaning that if it's running, uh, it's going to show you a green color. If stop, it's going to show you a red button. So this one you need to do some be creative on how to manipulate this button. But anyhow, these are the four elements that you need to have in your graphical user interface: the input, your graph, your nodes, and then your how you do the arrangement properly. And then the rest is up to you on your creativity. Okay, any question? So, so another thing. So any question? Kalau tak ada, kita tunjuk yang ini. Uh, okay, let's say that I'm going to change because we're doing the this simulation infinitely. So I'm going to change from set input into row profile, random row profile. Um, process random row profile where the minimum is going to be negative 0.075, maximum going to be 0.075 time going to be 0.01. Okay, so you can see it. Okay, now, okay, this is the simulation time, and then this is the graph. And later on, you can actually click this one, and then you can change the graph properties. Okay, so meaning y-axis, uh, display, tick. So you can do all the setting in there, so that you can explore this graph. Okay, and then later on, another thing that we can show is that how we can manipulate the image. Okay. So let's say that during the simulation, so let's say that show that you're going to simulate, let's say you're controlling a fan. So when you click that fan, you want to indicate that the fan is rotating. So we can use the image. So that image going to switch from one phase to another phase. So when the things keep on changing continuously, it's going to make that fan image looks like it's going to rotate. Okay. So same thing. So dashboard. So there are lots of indicator you can use. Okay, multi-stage image. For example, okay. Select scenario simulating editor. So I'm going to set this block. Okay. Kalau during zero state, I'm going to select this image. Okay. Another one. So to rotate this one. This one for the purpose of demonstration how it can work. Rotate. Let's say flip. Let's go. Okay, going to balik lah. Okay, back. So, one zero is this one. Oh, can only set the second. Okay. Then another one. For one state, we're going to select the one that being flipped. Okay. Then apply. Okay. Um, this one we are just playing around. Okay, I'm not going to provide with the specific application for this one. Just I'm going to show you how it can be used. Okay. So we're going to run. Okay. Okay. Select this one. Okay. Okay. So just run. So this is your image for this one. So if I toggle the switch button, you're going to switch. So if this thing keep on moving, let's say that one value or any value move continuously, so basically you can have image of this thing uh, like moving lah. So they want depend on your creativity lah. Okay, any question? That's all I want to demonstrate. It's just basic features. So if you want to go advanced, you can play around with your own model lah, graphical user interface. Okay, this is what you need, because you need to know this, because this is going to be you need to do it for your project. Okay, yang awak punya project saya tak siap lagi, dia punya there's some correction on the description of the project. Okay, any question? Any question? So, ada soalan tak?
Tak ada soalan.
Okay, faham nanti boleh buat. So make sure buat lah, jangan tanya saya lebih-lebih nanti. So, tanya tak tahu lah, memang silap besar lah. So, ini, okay, I'm going to share this file. So, nanti awak yang but nak the input, you need to key in on your own based on this value. Okay, and then the rest can start playing around. So if you feel that you're not sure, so just you can click this one and see where this option goes. Okay, and actually go to KT, and then it's going to show you it actually belong to this block KT. Okay, maybe we can explore this one. I'm going to share with you, but I'm using MATLAB Simulink 2021A. So for those who are using older version, you cannot open it unless you ask your friend who use 2021A to convert it to your version, to older version. And how to convert it, you can go to the save. Okay, this one, previous version. Export model to previous version of Simulink. Okay, so yeah, you can ask your friend to do that, because right now if you want to ask me to do it, and then I'm not sure because there are too many of you using different versions of Simulink. Okay, so I'm going to share with you this file and let's study this one for your own project. This one is just a focus model. Okay, any question? If no questions, then we're going to dismiss. So yeah, for your test, I haven't actually finished marking because yeah, last week I'm very busy. So this one I'm stuck marking, so I'm not finished yet. So hopefully when is the due date for your subject drop? Ada yang tahu tak?
I think it's already expired, doctor. Maybe.
Dah expired dah? Drop subject berapa bulan? Do you know the exact date for when can you drop the subject? Because usually student drop the subject after they know the test 1 result.
19-12 dah lepas dulu.
Dah lepas lah? Sebelum semester break?
Sebelum.
Sejak bila pula sebelum semester break? Selalunya selepas semester break. Kita 9 test itu kita buat berapa hari bulan? Sekejap 9 hari bulan. So for those who are thinking of dropping the subject, cannot do that. Okay. Usually the drop. Yeah. Let me check. I think last time we did Eh? Oh, how come? Ayo. Because usually the date for you to drop subject usually going to be when you finish during the semester break. Now they are actually making you to drop during the semester break. Okay, which is weird lah. Okay. So ni saya minta maaf lah, saya pun tak pasal saya sebab kebiasaannya memang kita drop subjek selepas first week after exam. 9 hari bulan je, during Thursday last week. Mana boleh sini? Tak apalah. Okay. So ada yang nak drop juga ke? So anybody thinking to drop this subject? Ada? Ada. Okay, good. Ada yang thinking nak drop? Kalau tak ada, baguslah. Okay. So if there is no other questions, yeah, possibly you can dismiss now. Okay, thank you for your time. Okay, so this is hopefully there's I'm not going to cancel any class anymore. Hopefully after this, because yeah, if I cancel, I need to replace it, and this is the last replacement class that I'm going to do. After this, you're just going to follow a normal schedule. And then for Lim, I forgot. Supposedly today's class we're supposed to do it at 9 a.m. Okay, I thought it's still at 11 a.m. Okay, so next week we're going to start it at 9 a.m. So when I give time or link at 11 a.m. So please remind me to do it at 9 a.m. because I might sometimes forgot about it. Okay, so if there is no other question, we can dismiss. Assalamualaikum and good night.
Thank you, doctor.